Hello guys, welcome to the YouTube channel Placement Badshah, and here today we are going to discuss about the recovering the binary search tree. So which is the question which is present in leetcode. And now let us look at the question. So here they have here in the question, so they have said that a binary search tree was present. A binary search tree was present, so we have swapped two elements, that means exactly two nodes by mistake, and then they will give the tree which is going to have the mistaken sequence, that is the mistaken tree. They will give us the mistaken tree. That means initially a binary search tree was present. In this binary search tree we have swapped the two nodes, and now it is not the binary search tree, it will be the binary tree. So hence they will give the sequence of the binary tree, and then we have to find the two elements which have been swapped with each other, and then after finding those two elements we have to reswap the two elements. If we reswap the two elements, then the binary search tree is going to be generated, and we have to return that particular binary search tree sequence. So we have to return the binary search tree sequence. That's it. So this is the concept what we have to do. Okay, now let us understand the concept behind this. So initially let us consider a tree in which so here 10 was present, and then here 11 is present, and here 2 is present, and then here so 3 is present. Here 20 is present, and 20 is left child be 18. So in order to in any kind of binary search tree question, if they ask you to recover the binary search tree or validate the binary search tree, you have to use only one kind of traversal, that is nothing but the in-order traversal. So in-order traversal will be very useful. So now let us write the in-order traversal of this tree. So the in-order traversal will be 2, 3, 11, 10, 18, and then it is 20. In the question they have exactly mentioned that they have swapped two elements. So in order to get those two elements and in order to swap them, we require two pointers. Let the name of those two pointers be first and second. So this is cleared. And while performing the in-order traversal, in order to compare the data, we require another two pointer. Let the name of that particular pointer be previous, and the name of the other pointer be current. So we are going to compare the data between this previous element and the current element. If the previous element has the data greater than that of the current element, then in that particular case we are going to mark the first element onto this previous one, and the second element will be marked for will be pointed to the current element momentarily. So if and only if the previous element is greater than the current element, but in this case it is 2 and 3 in this. So we are not going to do any kind of operations. If the previous pointer, if the previous value is less than the current value, then we will move on to the next node. Now the current is present here and the previous is present here. So previous is present here and the current is present here. Again we will compare the data. So this 3 is less than the 11. So hence again we will move on to the next element, that is C, and so here the previous pointer will be present. So when we compare the data, so here 11 is present and then here 10 is present. So hence the previous pointer's value, that is the previous node's value, is greater than that of the current node's value. Then we are going to point the first element to this 11 and then the second pointer to this 10. Okay. So and after that we will move on. Okay, so we will traverse further and we will check whether there is any other element, so which is okay, so which what we can say, which does not satisfy the ascending order condition. So here the current is present on 18, no, this and the previous will be on 10. Hence the previous value, that is 10, is less than 18. It is not a big issue. Now let us move the current to this 20 and let us move this previous pointer to the 18, and again we are going to compare the 18 with 20. So and 18 is less than 20. So hence it is clear that no other sequence is present in the tree which does not satisfy the ascending order. Okay, so which does not satisfy the descending order property, or which follows the ascending order property. Only 11 and 10 are the elements or the nodes in this particular sequence which are not going to follow the ascending order property. That means the 11 is greater than 10. In this situation, what we will do, we will point this first element, we will make the first pointer to point on this and second pointer to point on current, and then okay, so we will swap these two elements and okay, the binary search tree will be cleared. So but one thing, in order traversal must be performed, and I am going to explain the code. So here I have considered the okay, so two pointers, first and second, in order to point on that one, and I have also considered the previous pointer, and this previous pointer is used for the comparison of the data. So here void recover tree is the is a function what the leetcode question has been asked. Okay, so in order to evaluate, in order to perform the in order traversal and in order to update the first and the second pointer, I have created this in order function or the method, and after the updation of this first and the second pointer, we will swap the first value with the second value. First let us perform the in order traversal. If root is equivalent to null, in that situation we cannot do anything, we have to just return from this in order statement, that is in order method. And now let us perform the in order traversal. So we already know what the in order traversal is. First we are going to visit the left child of the subtree, and after that we will perform some kind of operation, and after performing the operation, so we will visit the right child. Okay, so in this and after doing this we will okay, so we are not going to return anything because it is a void function. Okay, so in this operation section, first thing, okay, after every traversal we have to update the previous node. That means the previous should follow the current node. So before that, let us create the current node what we were talking about in the discussion. So let the current node will be on root. Okay, and okay, initially the current was this one. Okay, so and we also have the previous, right? So first and foremost thing is the in order to perform the operation, in order to compare the things, we have to use the if statement. If the previous is equivalent to null, okay, so that means if the previous is equivalent to null, then in that case we cannot compare anything, right? So hence if the previous is not null, okay, and the previous data is greater than current's data, so this is the condition which is going to not satisfy the binary search tree condition. That means the previous element have a value which is greater than the current element. So that means here the previous element 11 is going to have a value greater than that of 10. So this is the thing what we have mentioned here, and the previous should not be null. Suppose if the previous is null, it is okay, it suggests us that the previous is present here and the current is pointing on the first element. In that case we cannot compare anything. Okay, so and we have to check one condition, if first is equivalent to null. So if first is equivalent to null, then in that particular case I have said, if the previous is pointing on this one, and okay, if you encounter the invalidation first time, we'll point the first and the second element on the previous and the current respectively. That means the first is going to point on 11 and the second is going to point on 10, and we will check whether any element is present in the next sequence which does not satisfy this condition. Because suppose here 9 is present, let us say here 9 is present, then or let us say 9 is present here. In this situation we can swap this 9 with 11 so that 9, 10, 11 sequence will be formed, so which follows the in order sequence, that is the binary search tree thing. If first is equal to null, make the first to point on the previous element, and along with at the same time make the second to point on the current element. And if the first is not null, that is the second case what we have discussed, that is see here the 11 and 10 was present. So let us consider a sequence like this. So 2, 3, 11, 10, 9 and 20. Let us consider this case. So initially, so we have traversed, and our so first node was pointing on this one and our second node was pointing on this one. Okay, and if we find, so this is one invalidation. Suppose if we find the second invalidation, then we have to just update the second pointer and we have to swap the second element with the first element. So after swapping we are going to get 2, 3, 9, 10 and 11, because in this situation, as we know that the first was greater than second. So this was the case. And if the let us consider that this is the previous and this is the current, in the first case. So we already know that the previous is greater than the current. Next thing, so the previous has been updated here and the current is present here. And again, if the previous is greater than the current, so which is nothing but, so let us consider this as C dash and this is C. So here it shows that the first previous was greater than the current element, and again after traversing further, this C dash was also this C was greater than C dash. Then actually if we swap this C with this P, that means if C dash comes here, then C dash will be less than C and this will be less than P. So hence, so what is the conclusion? We have to just update the second pointer and swap the first and the second element. So here we have to just update the second pointer to point on current. And along with this one, so we have to follow the current, right? So here we will after completion of this operation, so we will make the previous to point on the current, and then the current will move on further. So this is the thing what we have to do in order to recover the binary search tree. Let us run the code. So here in this leetcode it is not the data, so we have to specify it as val. So it is not the data, it is val, VAL. So yeah, it is working fine. So our solution has been accepted, and let us submit this code. Yeah, it is showing that our solution is 82.82% faster and 91.37% faster. So I am going to summarize the thing. So I am going to summarize so very briefly. So now let us consider let us consider an in order traversal 1, 2, 5 and then 3, and then so 6 is present, and then so 9 is present, and here the 4 is present. So this is the in order traversal what I have considered. This is the in order traversal of the tree. So we will so traverse so using 2 pointers, that is previous and current. So we will keep on traversing. If the previous value is less than or less than the current, then in that particular situation, so we won't do anything, so we just move forward, that is we just traverse forward. And now our previous is present here and our current is present here, and again the 2 is less than 5, so hence it is not a big issue. Okay, now let us so traverse forward. Okay, so how to traverse forward? Now the current element is present here and our previous is present here. So now the invalidation occurs, and hence we have to point our first pointer here and our second pointer on 3. Is this clear? And after doing that, we will check whether there is any kind of invalidation in this part. Okay, so now our current pointer will move on to 6 and our previous pointer will be present here, and we'll compare these two. There is no issue. So our current pointer will move on to 9 and our previous pointer will move on to 6. Again we'll compare the data. Again the previous value is less than current value, so hence it is not a issue. And now we will so traverse so forward. So and our current is present on 4 and our previous is present on 9. So here the invalidation occurs again. So we will take this second element. We will take this second element and we will update this second to this node. So because I have already explained, so if previous was greater than C and this C was greater than the new C dash, then by swapping these two elements, so we can get C dash is less than C and it is less than P. So hence we are going to swap these two elements. So that is the concept. So thanks a lot guys.